Today we're going to experiment with lenses and how light acts when passed through different shapes of lenses. Lenses are typically made of glass or transparent perspex, just like the glass block that we looked at before. The two main types of lenses that we need to know about are convex lenses and concave lenses. Convex lenses are thin at the top, thick in the middle, and then thin at the bottom again. Concave lenses are thin in the middle, but a bit thicker at the top and a bit thicker at the bottom. So they are different in shape, and the light that passes through these lenses acts differently too. Now let's experiment with these lenses. I have set up in a darkened room 3 light sources. So we have got a red, green and blue light source, and we have both of our lenses ready to place in front of the light sources to see how this interacts. Now, as I've mentioned, they're made of the same material as the glass block, but it will bend slightly differently because they have slightly different shapes. So let me place down the convex lens. Now, what you should notice is that the rays of light entering the glass block bend towards a point. The green light, which passes directly through the thick part in the middle, continues on in a straight line. The red one at the bottom bends up towards the green line, and the blue one at the top bends towards the green line. So what we find is that this lens brings everything to a point. It converges everything to a point. Now, if I move the lens, no matter where I move it to, the distance between the lens and this point is the same. The one thing that may change the distance that this focuses at would be the thickness of the lens itself. Now let's try it with a concave lens, the one that caves inwards. If we place that in a similar place to the convex lens, we notice that it spreads outwards when it is placed in front of the rays. So again, the green one that's passing through the middle seems to continue roughly on undeviated. The blue one, however, moves away from the green line, and the red one moves away from the green line. So this one causes diverging light. So it causes the light to spread outwards. Let's summarise our results. So we want to complete some ray diagrams using a convex lens and concave lens. So how does the light pass through a convex and concave lens? So let's start with our green middle rays. We saw that they didn't deviate much, they just travelled straight through in both examples. The blue rays within the convex lens started bending as it passed through the material, and even more when it exited the material. And it came to a point. The red ray done the same thing. So it moved towards the green normal, and then even more so as it left the glass, like so. So we should see that there is a point in which they cross over. And this point here is known as the focal point. So where all the light comes to focus. Let's complete the concave lens diagram. Now as it passes through, it bends away ever so slightly, and then even more as it leaves the material, like so. And then the same with the bottom ray. It bends slightly when it's in the material, and then a lot more when it leaves the material. Let's just finish this off with some arrowheads just so that we can see clearly from the diagram what direction the light is travelling in. So both diagrams show the refraction of light. The convex lens makes the light rays come to a point. The word for this is converging, so it's sometimes known as a converging lens. The concave lens makes the light rays spread apart. The word for this is diverging. So again, it's sometimes known as a diverging lens.